Hello and welcome to today's video solution. We will be answering the question which is in front of us, so let's start by giving it a quick read. It says, given that theta is small and is measured in radians, use the small angle approximations to find an approximate value of 1 minus cosine 4 theta all over 2 theta sine 3 theta for 3 marks. So let's first start by highlighting some important information given to us in the question. It is given that theta is small and measured in radians, use the small angle approximations. Okay. The reason why theta is small and measured in radians is important is because these are the conditions needed to use our small angle approximations. So what I want to do first is I want to write out or just quote from the formula book the small angle formula for cosine and sine. So we can start with cosine theta is approximately 1 minus theta squared over 2, and sine theta is approximately theta. Okay, so where do we go from here? Well, if we notice in the question, we have a cosine 4 theta as indicated by the pointer. So let's start by solving for cosine 4 theta. So cosine 4 theta would be approximately 1 minus 4 theta squared all over 2. Okay, and then this in turn equals 1 minus, well, 4 theta squared gets you 16 theta squared. 16 theta squared divided by 2 gets you 8 theta squared. Like that. Now, sine 3 theta, so that is approximately 3 theta. Right? So if we just put this all back into our expression, we have 1 minus cosine 4 theta over 2 theta sine 3 theta equals, well, what is cosine 4 theta? It is 1 minus 8 theta squared all over 2 theta 3 theta, because all we've done is substitute sine 3 theta for being 3 theta into this part, and we substituted 1 minus 8 theta squared into this part. So we end up moving from cosine 4 theta to 1 minus 8 theta squared and sine 3 theta to 3 theta. That's all good. Now let's just carry out some simple algebra. This equals, this equals 1 minus 1 plus 8 theta squared over 6 theta squared. 1 minus 1 disappears, so we are left with 8 theta squared over 6 theta squared, which equals 8 over 6, which simplifies to 4 over 3. For this question, you're awarded 3 marks. The first mark comes from attempting to do either cosine 4 theta or sine 3 theta and correctly substituting it into the original equation as we have done here. Your second mark comes from doing both cosine 4 theta and sine 3 theta into your equation and correctly simplifying it, or attempting to correctly simplify it. Your final mark, the third one, comes from getting 4 over 3 as your final answer. Thank you very much. I hope this video was easy for you to understand. We are told a curve C has equation y equals x squared minus 2x minus 24 root x, where x is greater than 0. Part A is asking us to find dy by dx first, and then part 2 is saying find d squared y by dx squared. So the first thing I want to do is rewrite y in terms of a way which will make it easier to differentiate. So we've got x squared minus 2x and then minus 24x to the half, like that. Okay, so to find dy by dx, okay, all we need to do is, for any term which is y equals ax to the n, dy by dx equals an x to the n minus 1. Alright then, so dy by dx equals 2x minus 2 minus 12x to the minus half. Okay, so moving on, now let's do d squared y by dx squared, so d squared y by dx squared equals, So to find d squared y by dx squared, what we need to do is we need to differentiate dy by dx with respect to x. Okay, so to do this, we need to just differentiate each of our terms in dy by dx with respect to x. So the derivative of 2x with respect to x is 2. The derivative of minus 2 with respect to x is 0, so we leave it. And then the derivative of minus 12x to the minus a half is positive 6x to the minus 3 over 2. There are 3 marks available for this question. The first 2 marks come from correctly differentiating y to get dy by dx. And then your third mark comes from correctly differentiating dy by dx to get d squared y by dx squared. Part B is asking us to verify that C has a stationary point when x equals 4. So a stationary point is when dy by dx at a certain x value equals 0. So what we need to do is we need to test whether dy by dx at x equals 4 is 0. So let's do that. Dy by dx at x equals 4 equals, so now let's plug in our x values. So we have 2 times 4 minus 2 minus 12 and then 4 to the minus 1 over 2. So let's start simplifying. So we've got 8 minus 2 minus, so 12 times 4 to the minus a half. 4 to the minus a half is the same as 1 over root 4, which is 1 over 2. So minus 12 times 1 over 2 gets us minus 6. And this, in turn, equals 0. Good. So now we just need to finish this by giving a concluding statement. So we're going to say something along the lines of dy by dx at x equals 4 equals 0. Hence, a stationary point at x equals 4. Okay. This question is worth 2 marks, all right? Your first mark comes from being aware that you need to substitute x equals 4 into your expression for dy by dx. So this line of working here will get you your first mark. Your second mark will come from showing that dy by dx equals 0, and then again using it in your argument to say hence a stationary point at x equals 4. Now bear in mind that saying dy by dx at x equals 4 equals 0 and hence a stationary point at x equals 4 are both required to get the second mark for this question. So if you only have one of them, you don't get any credit. So part C has asked us to determine the nature of the stationary point and give a reason for our answer. So to determine the nature of a stationary point, there is sort of one key rule you go by. If d squared y by dx squared at a certain x value, so x equals a, is greater than 0, this means the stationary point is a minimum. And if d squared y by dx squared at some other x value, so x equals b, say, is less than 0, then this is a maximum stationary point. So all we need to do is plug in x equals 4 into our expression for the second derivative and then see which case it meets. So we can say d squared y by dx squared at x equals 4 equals, so 2 plus 6 times 4 to the minus 3 over 2. So this equals 2 plus 6 over 8, which equals 2.75. Okay, so now here's where we need to be careful. We need to say that d squared y by dx squared at x equals 4 equals 2.75, which is greater than 0. Hence, stationary point is a, so we said if it is greater than 0, it's a minimum. So hence stationary point is a minimum. Okay, so This question itself is worth 2 marks. You get your first mark for being aware that you need to substitute x equals 4 into your expression for d squared y by dx squared. So that would be it. Your second mark comes from stating both that d squared y by dx squared at x equals 4 is 2.75, which is greater than 0. So this whole sort of section here, chunk, gets you 1 mark. Well, not 1 mark, 1 point, and then hence the stationary point is a minimum, is the next point. So you need both of these points to get the second mark for the question. We are told that figure 1 shows the sector AOB of a circle with center O and radius r centimeters. It tells us the angle AOB is theta radians and the area of the sector AOB is 11 centimeters squared. Given that the perimeter of the sector is 4 times the length of the arc AB, find the exact value of r. Okay, so to solve this first, I'm going to highlight some key information. So we are told that the sector has a radius of r. The angle AOB is theta radians, and it's important we're told it's radians so we know which of our formulae to use. And the area of the sector is 11 centimeters squared. The last piece of important information is it says the perimeter of the sector is 4 times the length of the arc AB. Good. So let's start solving the question. The first thing I'm going to do is we're going to write down an expression for the area of the sector and the perimeter. Okay, so the area of the sector, half r squared theta, and the perimeter is the length of the arc AB plus both of the radii. So what that is, it is r theta plus 2r. Okay? So let's use what we've been given in the question to formulate some more formulas. We are told that the area of the sector AOB is 11 centimeters squared. So we know that half r squared theta equals 11. We also know that the perimeter of the sector is 4 times the length of the arc AB. So we know that r theta plus 2r equals 4r theta. Okay, let's start by solving r theta plus 2r equals 4r theta. So we know that 2r equals 3r theta. And what we can do is we can divide both sides by r because we know that r is a unit of measurement, and in this case r isn't 0. So what we can do is we can say 2 equals 3 theta, and therefore theta equals 2 over 3. Okay. Now what we can do is we can take this value of theta and we can put it into our value for half r squared theta. So what we end up with is half r squared, and then theta is 2 over 3 equals 11. So half times 2 over 3 is the same as 2 over 2 times 3. The 2's cancel, so we get 1 over 3 r squared equals 11. We multiply both sides by 3, so we have r squared equals 33, and this means that r equals the square root of 33. As for the marks for this question itself is worth 4 marks. Your first mark comes from stating half r squared theta equals 11. Your second mark comes from stating that r theta plus 2r equals 4r theta. Your third mark comes from being aware that you need to solve theta equals 2 over 3 and that you attempted to substitute it back into your expression for half r squared theta equals 11. So this line over here is enough evidence to get you your third mark. Your fourth mark comes from correctly solving r and getting r equals root 33. And remember, they wanted the exact value of r, so don't convert it to decimal or try and do anything like that. Just r equals root 33. We are told the curve with equation y equals 2 ln 8 minus x meets the line y equals x at a single point x equals alpha. Part A is asking us to show that alpha is between 3 and 4. Okay. the first thing we need to do first is come up with some function which represents the point of intersection. Now, at the point of intersection, the x coordinates and the y coordinates are the same. So what we can do is we can set the y coordinates equal to have 2 ln 8 minus x equals x. Okay, so the point of intersection will be where 2 ln 8 minus x equals 0. All we've done is subtracted x from both sides. And I'm just going to let this expression here equal to fx. So we're going to say fx equals 2 ln 8 minus x, like that. Okay, so how do we show that a root to an equation is between two values? Well, first we need to test both of these values and show that they are there is a sign change. So what we need to do is we need to prove so f3 and f4 have a different sign. Okay, this is fundamentally what we're trying to argue. So let's solve it. We're going to say f3 equals 2 ln 8 minus 3 is 5 minus x, which is minus 3, equals 0.22. Okay, and in brackets here I'm going to write positive. Okay, now on the other side, under it, sorry, I'm going to write f4 equals 2 ln, now 8 minus 4 is 4, minus x is minus 4, which equals minus 1.23. Okay, which is negative. And the reason I'm writing this is just so the examiner knows clearly, yep, we know f3 is positive and f4 is negative. So that's good. Now we've got the bulk of our argument done. We just need to finish it with a good concluding statement. So what you need to say on a question like this is you need to say fx changes sign, okay, between 3 and 4. And you also need to say one more key thing. The function is continuous. Okay, continuous. Right, this one is a really important point, and it just means at each point throughout 3, 4, so actually, yeah, throughout 3, 4, each x value leads to a specific y value. Okay. These two conditions mean that there is a root. Okay? So this question is worth 2 marks. Your first mark comes from attempting to find f3 and f4 and getting that fx equals 2 ln 8 minus x. So this part here, and then understanding that you need to look for f3 and f4, all of these contribute towards your first point. Okay. Your next point comes from getting 0.22 minus 1.23 and doing your argument. So stating explicitly that fx changes sign and the function is continuous. Okay. So you need this positive and negative shown, so 0.22 and minus 1.23, and your concluding statement of fx changes sign and is continuous, okay, all to get your next point. Part B is showing us a graph which is labelled figure 2. It says figure 2 shows a graph of y equals 2 ln 8 minus x and the graph of y equals x. It says the student uses the iteration formula xn plus 1 equals 2 ln 8 minus x to the n, where n is a natural number, in an attempt to find an approximation for alpha. This question says, using the graph and starting with x1 equals 4, determine whether or not this iteration formula can be used to find an approximation for alpha, justifying your answer. Well, we are told we need to use a graph, or using the graph provided, and we're also told that we need to start with x equal, the first x value is 4. Okay, and now we need to determine whether or not the iteration formula can be used to find an approximation for a, and alpha, sorry, and we need to justify our answer. So because we need to use a graph, what we can do is we can look at drawing either a staircase or a cobweb diagram. So a staircase diagram, remember, goes something along the lines of this, and a cobweb diagram sort of spirals in like this, like a cobweb does, okay? And the way you determine if a solution exists is if either the staircase or the cobweb converges. And if it converges, then that means the cobweb or the staircase is getting closer to a particular value, and therefore that particular value can be seen as an approximation to the question. The other case is diverges, and if the curve diverges, or if the cobweb or staircase diagram diverges, that means that it's getting further and further away from a specific value, and therefore that method isn't a good way to find an approximation to our answer. So what we can do now is we can look at what we need to draw. So the first thing to do is to draw a vertical line from our x-axis to our curve y equals 2 ln 8 minus x. So let's start by doing that. Okay. The next thing we do is draw a horizontal line from y equals 2 ln 8 minus x to y equals x. Like this, okay? From y equals 2 ln 8 minus x, we draw a vertical curve to y equals x, and then a horizontal curve from y equals 2 ln 8 minus x to y equals x again. And this process just keeps repeating. And let's do a few just to be 100% sure, yep, it converges to where we need it to. Okay. So, as we can see from the curve, it does get closer and closer and closer to a point. So we know that it converges. Now, that's only part of the argument, because remember, we have to justify it. So what we need to say to get our marks for this question is we need to say the iteration formula can be used, okay, to find an approximation for alpha. And we need to word it exactly like this, because saying the words can be used means, yeah, we're answering your question directly, it can be. And by writing find an approximation for alpha, we're using what the examiner has given us, and we're effectively throwing it back at them to say, yeah, we've understood the question and we're doing as you want. And remember, we need to justify our answer. So just drawing the diagram isn't enough, so we can write something along the lines of, because the cobweb spirals inwards for our cobweb diagram. Okay. This way, you've covered all your bases. Okay, you've used your graph, and you're using what you know or what you've learned from that graph to formulate your final justified answer. Okay. This question is also worth 2 marks. The way you get your 2 marks for this question, your first one comes from an annotated cobweb diagram on figure 2, and you need to start at x1 equals 4, and you need to have at least 2 spirals. So if we look here, we have one spiral which goes along here, and we have a second one. Okay, so we know that we have gotten 2 spirals, and that gets us our first mark. Okay then, so we can put a nice little tick next to our curve. The second mark we get comes from our argument, or our justification of our answer. And to get this mark, you need to explicitly state it can be used. Now this one's important in the mark scheme, it's bolded, which means the examiners are looking for it. And also you need to say the cobweb spirals inwards. Okay, so both of these points, all right, like that, will get you your second mark. If you're missing either one of them, you cannot get that second mark. Okay. We are told, given that y equals 3 sine theta over 2 sine theta plus 2 cosine theta, show that dy by d theta equals a over 1 plus sine 2 theta, where a is a rational constant to be found. The first thing we're going to do is highlight the final form the examiner wants us to give our answer in, as well as where a is a rational constant, because those are both key in how we're going to direct our answer. So y equals 3 sine theta over 2 sine theta plus 2 cosine theta. This is what's called a rational function. And the way you differentiate functions like this, so you're given it in the term of y equals u theta over v theta, dy by d theta equals the derivative of u theta v theta minus u theta times the derivative of v theta all over v theta squared. Okay, so the first thing I'm going to do is assign u theta and v theta functions from our question. So u theta is our numerator, which is 3 sine theta, and v theta is our denominator, which is 2 sine theta plus 2 cosine theta. So let's write these down. U theta is 3 sine theta, v theta is 2 sine theta plus 2 cosine theta. Okay, so this implies that the derivative of u theta equals 3 cosine theta, and the derivative of v theta is, differentiate each term separately, 2 sine theta becomes 2 cosine theta, and 2 cosine theta differentiates to minus 2 sine theta. Okay, let's plug these all into our expression for dy by d theta. Dy by d theta, so the derivative of u theta, 3 cosine theta times 2 sine theta plus 2 cosine theta minus, so u theta is 3 sine theta, and then derivative of v theta is 2 cosine theta minus 2 sine theta, and all of this will get divided by v theta squared, which is 2 sine theta plus 2 cosine theta all squared equals, okay, let's start expanding these. So 3 cosine theta times 2 sine theta gets us 6 cosine theta sine theta. 3 cosine theta times 2 cosine theta gets us 6 cosine squared theta, like that. Then minus 3 sine theta times 2 cosine theta is minus 6 cosine theta sine theta, and minus 3 sine theta times minus 2 sine theta is positive 6 sine squared theta. All of this is divided by, okay, so 2 sine theta, 2 cosine theta. We first do 2 sine theta squared, which is 4 sine squared theta. Now the last one is 2 cosine theta squared, which is 4 cosine squared theta. And then we multiply the inner two, which gets us 4 cosine theta sine theta plus 4 cosine theta sine theta. Okay then. So the next step is to see what we can cancel out. The first thing we're going to cancel out is 6 cosine theta sine theta and minus 6 cosine theta sine theta. This means we are left with dy by d theta equals 6 and then cosine squared theta plus sine squared theta all over 4 cosine squared theta plus sine squared theta, and then 4 cosine theta sine theta plus 4 cosine theta sine theta is plus 8 cosine theta sine theta, like that. And what I've done with this 6 and 4 is I've taken out a factor of 6 from cosine squared theta and sine squared theta, and I've taken out a factor of 4 as well from here. Okay. This is where I'm going to introduce two trigonometric identities. The first one I'm going to introduce is cosine squared theta plus sine squared theta equals 1. And the second one I'm going to introduce is 2 sine theta cosine theta equals sine 2 theta. Right, and let's just put that in brackets. Okay then, so let's simplify this. The first one, 6 cosine squared theta plus sine squared theta, will take 1. So this becomes 6 times 1 over, again, 4 cosine squared theta sine squared theta.
So this will become 4 times 1. And then 2 sine theta cosine theta can be used to do 8 cosine theta sine theta, because 8 cosine theta sine theta is the same as 4 times 2 sine theta cosine theta, which is just going to be plus 4 times sine 2 theta, like that. Okay, so what we can do is we can just rewrite this. So we can say this equals 6 over 4 plus 4 sine 2 theta. Now what we can do is we can divide the numerator and the denominator by 2, because it will simplify them. So we can say dy by d theta equals 3 over 2 plus 2 sine 2 theta in brackets. Sorry, I've got brackets on this one. And what we can do then is take 3 over 2 out as a factor. So this equals 3 over 2 times 1 over 1 plus sine 2 theta. And the final thing we can do is we can say, therefore, dy by d theta equals 3 over 2 all divided by 1 plus sine 2 theta. Okay, and just for safe measure we can say therefore a equals 3 over 2, like that.
So this question is worth 5 marks. Your first mark comes from getting an expression for dy by d theta as I've gotten up here. Okay, that will give you your first 2 marks for the question. Right. Your third and fourth mark are sort of together, and it's in the sense that you need to use cosine squared theta plus sine squared theta equals 1 and 2 sine theta cosine theta equals sine 2 theta correctly to get a representation of dy by d theta in terms of something like this. Okay, so 6 over 4 plus 4 sine 2 theta is enough evidence of this step to get you both your marks. Now, if you've used sine squared theta plus cosine squared theta equals 1 or 2 sine theta cosine theta equals sine 2 theta correctly once, you will get 1 mark for it. But if you use them both correctly all the time, then you get 2 marks. Your final mark is entirely taking your answer from this stage to this stage and finalizing at this stage to get this as your final representation of dy by d theta. So this one earns you your 5th and final mark. And just a note for writing a equals 3 over 2. In the answers, it doesn't explicitly state that you have to say a equals 3 over 2, but it does, and I'll read it for you. It says fully correct proof with a equals 3 over 2 stated, but allow for example, as we've gotten over here. So writing just this will be enough to get you the mark, but some mark schemes may be a bit more strict and require you to explicitly state that a equals 3 over 2. So definitely write it. You don't lose anything, and it doesn't take any effort to do so. We are given figure 3, where we are shown a line L and a circle C. It says the circle C has centre with coordinates 7, 5. We are also told the line L with equation y equals 2x plus 1 is the tangent to C at the point P, as shown in figure 3. Part A is asking us to show that an equation of the line PA is 2y plus x equals 17 for 3 marks. So I'm going to start by highlighting some key information. The circle has centre A with coordinates 7, 5, so that is a key piece of information. I'm going to highlight the equation of L, which is 2x plus 1, and I'm also going to highlight that it is a tangent to C at point P. Okay, so first we are told that the line L is a tangent to C. And the reason why this is an important part is because if we were to annotate our diagram and draw a line from P to A, this line is a radius of circle C. So R and R equals radius of C. And from GCSE, you should remember that a radius and a tangent to a line at a particular point are perpendicular to each other. So what is a key characteristic of two perpendicular lines? Well, what we can say as for part of our answer is for perpendicular lines, okay, and in our case our two perpendicular lines we're referring to are our tangent and our radius. The gradient of line 1 times the gradient of line 2 equals -1. So that means for our question that the gradient of our tangent, so we're going to use m for gradient, t for tangent, times our gradient of our radius, so r is our radius, should equal -1. So if we look now, what do we have to solve this question? We are told y equals 2x plus 1. So from here, what we can see is that the gradient of the tangent equals 2, okay, because it's y equals mx plus c. M is our gradient and therefore m is 2. So m for our tangent is 2. So what we can do is we can say 2 times the gradient of our radius equals -1, and therefore the gradient of our radius is -1 over 2. Okay. Now remember we need to find an equation for the line. So there are a few ways you can use to find the equation, but the one I'm going to use is the following formula, which says that y minus some y coordinate equals the gradient times x minus some x coordinate, okay, where these x1 and y1 is a point, comma y1 is a point on the line. Let's just fix that. x1, y1 is a point on the line. Okay, so if we come back to our diagram, we can see that PA is this line here, okay, and we can see that it goes through point A. Now for A, we know that our x coordinate of A is 7 and our y coordinate of A is 5. So that means we can plug in x1 into here and we can plug in y1 into here. So let's do just that. Y minus our first y coordinate is 5 equals m, which is -1/2 from over here. So let me just put that in like that. So -1 over 2 times x minus, now our x point is 7. So let's write 7 like that. Now remember, we need to give it as a specific form, so we need to do some rearranging. I'm going to multiply both sides by 2 first to get rid of this -1/2 here. So y minus 5 times 2, this is going to become 2y minus 10 equals minus, and then brackets, x minus 7. Remember to keep your minus on the outside because we haven't gotten rid of it yet. Let's expand these brackets. So we have 2y minus 10 equals minus x plus 7. And this means 2y, we're going to bring this x here to the other side. So we're going to have 2y plus x equals, and then this minus 10, we're going to move it to the other side to get positive 10. So positive 10 plus 7 equals 17. That is exactly the form required here. So we're going to just write as required, like that. So this question is worth 3 marks. Your first mark comes from getting the gradient of your radius as being -1/2. Your second mark comes from combining your gradient of -1/2 with the point 7,5 to get an equation in this form. So this line over here, down here, is enough to get your second mark. Your third mark comes from correctly completing your proof to get 2y plus x equals 17. Okay, so part B is asking us to find an equation for the circle C for 4 marks. So at the top here, I've just written some key information from previous questions that was given us to prior, so we can solve it. So to find an equation for C, we first need to recall what form C will take. So C is a circle, which means the equation it takes is x minus some center squared plus y minus some other, the y coordinate of the center, equals the radius squared. Okay, so to solve this, we need to find the center of the circle and the radius. Now recall point A was the center of the circle, okay, which means we know that x minus, so we've got our first x coordinate here, which is 7 squared, plus y minus our y coordinate of the center is 5 squared equals r squared. Great. So that's one bit done. Now all we need to do is find the radius. So if we look back at our diagram here, our radius is the distance between points P and A. Okay, so what we need to do is we need to find the distance between P and A. And how do you do that? Well, you first need to find the coordinates of P and have the coordinates of A. So let's start by finding the coordinates of P. Now recall that line L is tangent to the circle at point P, and PA goes through the point P as well, which means they share the common point P. So simultaneously solving PA, so line PA and line L, will allow us to find the coordinates of P. So let's do that. We know that L, y equals 2x plus 1, and for PA, 2y plus x equals 17. So what I am going to do is I am going to plug in our expression for y into 2y plus x equals 17. So what we will end up having is 2, and then our expression for y here is 2x plus 1 plus x equals 17. Okay, so let's expand the brackets. So 2 times 2x is 4x. 2 times 1 is 2. So 4x plus 2 plus x equals 17. 4x plus x, that gets us 5x plus 2 equals 17. 5x, subtract 2 from both sides, so we get 5x equals 15, and therefore our x coordinate equals 3. So to find our y coordinate, we can just put x equals 3 into either one of our PA or L and get the y value. I'm going to put it into L because it's already in the form of y equals something, so we have less to rearrange. So I'm going to say this implies that y equals 2, and then our x value is 3 plus 1, which equals 6 plus 1, which equals 7. Okay. So therefore, what I want to do, just to make it super clear to the examiner, is I want to say that P is 3, 7, like that, okay? Or P equals 3, 7. Either one is fine. So next, we need to find the distance PA. So the way you would go about finding the distance between 2 points is you would say the distance of PA, so this line denotes the modulus, which means distance, equals the square root of, okay, px minus ax squared plus py minus ay squared. Okay, so this is just sort of a more elaborate version of the Pythagoras theorem. So let's put our values in and solve this. Px is going to first the square root. Px is 3 minus, now ax, if we go back, come back to the top, we see is 7. Okay, so it is 3 minus 7 squared plus, now py is 7 and ay is 5, okay, squared. So this equals the square root of 3 minus 7 is minus 4, and minus 4 squared is 16, plus 7 minus 5 is 2, 2 squared is 4, which equals the square root of 20. Okay. So what we can write here is
r equals the square root of 20, and because remember, for our equation of the circle, we need r squared. So therefore, r squared equals 20. Okay? Now we've got all the information we need. Let's just present it clearly to the examiner. So what we can say is equation of C is x minus 7 squared plus y minus 5 squared equals 20, like that. This question is worth 4 marks. You get your first mark for knowing that you need to simultaneously solve 2y plus x equals 17 and y equals 2x plus 1. So this step up until about here will be sufficient evidence to get you your first mark. Your second mark comes from getting p equals 3, 7, so as this. Your third mark comes from understanding you need to find the length of PA and getting root 20 as your answer. And your fourth mark comes from getting the full equation of C, so plugging in the point A as well as your radius, so that's your fourth mark there. We are told the line with equation y equals 2x plus k, where k doesn't equal 1, is also a tangent to C. Part C is asking us to find the value of the constant k for 3 marks. So we are told that y equals 2x plus k is a tangent. So what this means, when there is a tangent implies a solution exists. Okay? It just means that at some point they intersect and therefore it can be solved. So the way I'm going to solve this is I am going to end up by plugging y equals 2x plus k into our equation for C. But first what I'm going to do is I'm going to expand C to make it easier to substitute y into. So we have C is x squared minus 14x plus 49 plus y squared minus 10y plus 25, which equals 20. Okay? Then what I'm going to do is I am going to collect like terms. So I'm going to say x squared minus 14x plus y squared minus 10y, and then 49 plus 25 is 74, and then we're going to take this minus 20 from this side, this 20 from this side, and subtract it. So 74 minus 20 is going to be plus 54, like that. Okay, so what I'm now going to do is I'm going to plug in our y into here and into here and expand and solve. So we're going to end up with x squared minus 14x plus, and then 2x plus k squared minus 10 times 2x plus k plus 54 equals 0. Sorry, we've got equals 0 here. Okay, that's good. So let's carry on. X squared minus 14x plus 2x plus k squared. So first we do 2x times 2x, which is 4x squared. Then you do 2x times k, which is 2kx, and then you do k times 2x, so the other side, which is also 2kx. When you add those together, you get 4kx. And then you do k times k, which is k squared. Minus 10 times 2x is minus 20x. Minus 10 times k is minus 10k. Plus 54 equals 0. Okay, so now I'm going to combine terms and take out factors just to make it easier and simpler. So x squared and 4x squared. Well, this becomes 5x squared. We then have minus 14x minus 20x plus 4kx, which is going to be 4k minus 34x, so plus, okay? And the reason is because minus 14 minus 20 is minus 34. 4k plus minus 34 is the same as 4k minus 34, and we've taken x out as a factor. So then all we have to do is our non-x terms or our constants, and this is going to be plus k squared minus 10k plus 54, like this, equals 0. Now the reason I've done it like this is because notice it is the form of ax squared plus bx plus c. Okay, so what we can do now is we can actually use our quadratic formula to solve for k. And the way we do this is we need to know, because it's a tangent, okay, we need to be aware that a tangent specifically implies one solution only. Okay, so this is key. So how do you use a quadratic to get one solution? Well, this means that the discriminant, or b squared minus 4ac, has to equal 0. Because if it's greater than 0, there are two distinct solutions. And if it's less than 0, there are no real solutions. Okay? So, let's solve b squared minus 4ac equals 0. A is 5. B is 4k minus 34, and C is k squared minus 10k plus 54. So I am going to put all of these into our formula. So b squared, so 4k minus 34 squared minus 4, A is 5, let's just actually neaten that up a bit, 5, and then k squared minus 10k plus 54, so k squared minus 10k plus 54, and remember this all equals 0. Okay, so let's start by going through 4k minus 34 all squared. The first thing to do is 4k times 4k, which is 16k squared, so 16k squared. Then we need to do 4k times minus 34, so 4k times minus 34 is minus 136, but we need to do it twice because it is being squared, so we multiply that by 2 to get minus 272k. And then finally, minus 34 squared is positive, 1156. Okay. Now we've got minus 4 times 5 times k squared minus 10k plus 54. So what I'm going to do is I'm going to combine these just to make it simpler to get minus 20 like that. So minus 20 times k squared, that gets us minus 20k squared. Minus 20 times minus 10k will get us positive 200k. Okay, so positive 200k. And minus 20 times 54, like this, is going to get us minus 1080, and this all equals 0. So then the next step from here is just to combine some stuff. So we have minus 16k squared, 16k squared minus 20k squared, and what that becomes is minus 4k squared. Then we have minus 272k plus 200k, which is going to be minus 72k. And then we have 1156 minus 1080, and let me just check on my calculator. That gets us positive 76, like this, which equals 0. Now I'm going to divide both sides by minus 4. So we're going to get k squared. So minus 72 divided by minus 4 is plus 18k. And then 76 divided by minus 4 is minus 19, which equals 0. So we are now left with a quadratic. So all we need to do is find two numbers which multiply to get minus 19 and add to get 18. So what I'm seeing here is to get minus 19, well, the only ones you have are either minus 1 and 19 or minus 19 and 1. But since we have 18k here, we know we need the 19. So 19 minus 1 gets us 18. So we're going to have k plus 19 times k minus 1, which equals 0. Okay? So from here, either k plus 19 equals 0 or k minus 1 equals 0? Well, if k minus 19 equals 0, we have k equals minus 19. If we have k minus 1 equals 0, we have k equals 1. But bear in mind, in our question, we are told that k cannot equal 1, okay? Which means, when we look here, we should write something along the lines of k equals minus 19 and 1. But since k cannot equal 1, therefore k equals minus 19. So the whole point here is you are showing the examiner that you are aware that there are two solutions, but because of the restrictions placed on k, you can't have k equals 1, and therefore k equals minus 19. This question is worth 3 marks. Your first mark now this question, actually, before I go through that, there are quite a few ways the mark scheme says you could solve it. And I chose the one which is probably more work, but it's a more straightforward or a more logical approach, okay? And if you are careful in what you're doing, it's probably going to be easier and sort of more reassuring doing it this way. So the first mark you get is for substituting y equals 2x plus k somewhere into your equation for c. So in the mark scheme, this line is listed as the final line, and that means if you include this, you have done enough work to get your first mark. Your second mark comes from knowing that you need to use b squared minus 4ac to find the solution to k. So you need to use b squared minus 4ac equals 0, or physically showing that b squared minus 4ac equals 0. So this line here is also sufficient evidence to get you your second mark. And your third mark comes from just getting k equals minus 19. We are told, given that k is in the set of positive integers, show that the integral of 2 over 3x minus k with respect to x from k to 3k is independent of k. The first point I want to pick out is when it says independent of k, what we need to show is there is no k term or variable in our answer. Okay? So that's going to direct us on how we need to present it. Now, to integrate what we have over here, what I'm going to do is I'm going to use a rule which says the integral of a constant, say a, over bx plus c, as we have in our question with respect to x, equals a over b times the natural log of bx plus c, like that. And then obviously your constant of integration like that. Okay, so what I'm going to do is I am going to use this formula to evaluate our integral here. All right, so we can see that the integral of 2 over 3x minus k with respect to x equals, so first what I'm going to do is I'm just going to evaluate this integral without the limits of integration, just as a first step to show the examiner that we can actually evaluate the integral, because this is a marking point. So we're going to say, so we can see here that our a is 2 and our b is 3, so this is 2 over 3 times the natural log of 3x minus k. Okay, so what this means is this implies that the integral from k to 3k of our expression, 3x minus k, like this, with respect to x, is, or can be written as 2 over 3 ln 3x minus k, and then 3k and k like that. Okay? So this is a correct notation on how you want to present your answer. So what we need to do is we need to substitute first our 3k into our x. Okay, so what we will end up with is this equals 2 over 3 ln, so 3x times 3k is 9k minus k,
and then subtract, because remember, when you're taking, when you're going between the limits, you need to subtract 2 over 3 ln 3k minus k, following the same logic. Okay? So, this equals 2 over 3. I'm going to take this out as a factor, or as a constant, and then we're going to have ln. Now 9k minus k is 8k, and then 3k minus k is 2k. So ln 8k minus ln 2k, like that. Now we are going to use a rule that if you have ln a minus ln b, this equals ln of a divided by b, like that. Okay, it's one of the log rules. So this means our integral ends up being 2 over 3 times the natural log of, well, we're just going to put 8k for our a, so that's going to be 8k, divided by, and then 2k for our b, which is going to be 2k, like this, which equals 2 over 3 times the natural log of 4. Okay, now just to finish it off, we can just write a concluding statement to say our result for the integral has not got the term k present, therefore it is independent of k, like that. So this question is worth 4 marks. Your first mark your first 2 marks actually come from getting 2 over 3 ln 3x minus k. So this line here as your solution to evaluating the integral, which is why I did it as its own step. Okay, so here this line gets you 2 marks. Your third mark comes from getting this line, so plugging in your constants of integration, plugging in your limits of integration to get this expression here. And then your fourth mark comes from being aware that you need to use this rule and to get this expression and to finish with this answer. Okay, bear in mind you don't technically get a mark for your concluding statement, but it is still a good idea to include one because some mark schemes may request it. Part B is asking us to show that the integral of 2 over 2x minus k all squared with respect to x from k to 2k is inversely proportional to k. So when it says inversely proportional to k, it means the final answer will be of the form a over k, where a is just a constant. And this also means directly proportional to 1 over k, like that. Okay. So what I'm going to do first is I'm going to evaluate just the integral of 2 over 2x minus k all squared with respect to x. I'm going to leave the limits out just for a second. So what we're going to say is the integral. So we're going to let u equal 2x minus k. And that's going to mean du by dx equals, well, the derivative of 2x is 2, and the derivative of minus k with respect to x is 0, so just 2. This implies, doing some rearranging, that dx equals half du, like that. So what we are left with is the integral of 2 over u squared times 1 over 2 du, like that. Okay? So this means we have the integral of half and 2, so this 2 here and this half here will cancel out, like that. So we are left with the integral of 1 over u squared du, which equals the integral of u to the minus 2 du. Now add 1 to the power, divide by the new power, which means we get minus u to the minus 1, or minus 1 over u. Now as a final step, I'm just going to substitute 2x minus k back in for u. So we're going to say, therefore, the integral of, which is 2 over
2x minus k all squared dx equals minus 1 over, now our expression for u is 2x minus k, like that. All right? So let's put that in brackets. Now what I'm going to do is I'm going to evaluate the integral with the limits. So we're going to say this implies that the integral from k to 2k of 2 over 2x minus k all squared with respect to x equals minus 1 over 2x minus k from 2k and k, like that. Now I'm going to plug in our 2k and k for our x. So the first one to do is to put in our 2k. So this means we will end up with minus 1 over 2k times 2k times 2 is 4k minus k, so like that. And then remember we're going to do minus. Now minus again, because remember we've got this negative here. Okay, we're going to plug in our k for x, and we get minus 1 over 2k minus k, like that. This equals, we have minus 1 over 4k minus k, so this is minus 1 over 3k. Now minus and minus here will make a plus, so plus, and then 1 over 2k minus k is 1 over k, like that. Okay? When you add these, you will end up with this equals 1 over k minus 1 over 3k is the same as saying 3 over 3k. So all I've done is brought this one to this side and multiplied the numerator and denominator by 3 to preserve the fraction, minus 1 over 3k, which equals 2 over 3k. All right? Which is our answer to the question. So what we can write is just a concluding statement. We say the integral result is 2 over 3k, which is of form a over bk, and therefore, actually when you write therefore you use the 3 dots, and therefore equals or means it is directly proportional to 1 over k. Okay, so remember this symbol I've drawn here is directly proportional, not an and. Let's see if I can draw. There we go, something like that. Okay, this question itself is worth 3 marks. Your first mark comes from this line here, which gets the integral of 2 over 2x minus k all squared with respect to x is minus 1 over 2x minus k. So you need to have this line to get your first mark without evaluating the limits. Your next mark comes from plugging in your limit to get this line over here. So this line is sufficient evidence to get your second mark. Your third mark comes from getting that the integral is 2 over 3k, like this, and being aware that this means it is inversely proportional. Okay, so the mark scheme has put that in brackets, which means it's not technically required, but concluding it and saying, yep, this means that it is inversely proportional to k, or having this symbol here, is a good idea. The depth of water, d meters, in a harbour on a particular day is modelled by the formula d equals 5 plus 2 sine, and then brackets 30 times t in degrees, where t is between 0 and 24, where t is the number of hours after midnight. A boat enters the harbour at 6:30 a.m. and it takes 2 hours to load its cargo. The boat requires the depth of water to be at least 3.8 meters before it can leave the harbour. Part A is asking us to find the depth of the water in the harbour when the boat enters the harbour. Okay, for 1 mark. So this question actually is pretty straightforward. The first thing we're going to have to do first, though, is convert 6:30 a.m. into a duration after midnight. So because remember, t is the number of hours after midnight, and it enters at 6:30 a.m. So this would be 6 hours and 30 minutes, or because remember, t is in hours, 6.5 hours. Okay. Then from here, it's a pretty straightforward. All we need to do is we need to say that d equals 5 plus 2 sine, and then in brackets 30 times 6.5, okay, which equals 4.48 meters. Okay, you need to remember your unit. You get 1 mark for this question, and that 1 mark comes from explicitly getting the final answer. Now you need to have your units, okay? You can't get your final mark without having any units. Part B is saying find to the nearest minute the earliest time the boat can leave the harbour. And bear in mind, it says solutions based entirely on graphical or numerical methods are not acceptable. So we need to use an algebraic method to solve this question. So, effectively, what the question is saying is, it's saying the boat requires the depth of the water to be at least 3.8 meters. So I'm just going to pick that out in bold, okay, before it can leave. So what we need to do is we need to find at what t is d equal to 3.8 meters, okay? So what we need to do is we need to plug in our value of 3.8 into our expression for d and use that to solve for t, okay? So we've got our equation here, and I'm just going to do exactly that. We're going to say 3.8 equals 5 plus 2 sine 30t, like that, okay? I'm going to bring the 5 to the other side, so we're going to have 3.8 minus 5 is minus 1.2 equals 2 sine 30t. I'm going to divide both sides by 2, so you have minus 0.6 equals sine 30t, like that. I'm going to flip these around, so we have the sine 30t on the left-hand side, sine 30t equals minus 0.6, and I'm going to take the inverse sign, so 30t is going to be the inverse sine of minus 0.6, and this equals, so if I check on my calculator, 36 minus 36.869, etc. Now, the problem here is we have an expression for 30t, okay? And that means 30 times our period of time. Now, we can't have a negative period of time, which is what minus 36.869 here implies. So what we need to do is set, just a little comment here, t has to be greater than 0, therefore 30t also has to be greater than 0, okay? And we know that the period of a sine wave, so if I draw a little sine wave for you here, okay, when you do this, all right, the number of degrees between this point and this point is 360 degrees. So what we need to do is we need to use this information, okay, to add 360 degrees to our time for 30t. Right, so what we're going to say is 30t equals minus 36.86, etc., plus 360, okay, which equals, if I put it into my calculator, 323.13, etc. Right? If we solve for t, this means we can say t equals 323.13, etc., over 30, which equals, let me just fix that 0 to make it clearer. So we do this divided by 30, and you would get 10.77 hours, okay? 10.77 hours. Now, we're looking for a time, which means we need minutes with our answer, okay? So,
what we do is we take away 10 hours from our time. So we have 10 hours and 0.77 times 60 minutes, which is the same as 10 hours. And if I do 0.77 times 60, we have 46.2 minutes, or 10 hours and 46 minutes, because we round it to the nearest minute as we have in our question. Okay? So 10 hours 46 minutes after midnight is the same as 10:46 a.m. So we say the boat can leave at 10:46 a.m. Now, an important point to note here is technically at 10:46 the depth isn't exactly 3.8. It's still not there yet, but the question asked us to round it to the nearest minute. Okay, so as long as you're between 10:46 and 10:47, if you wrote either one of those answers, that's correct. Okay, because technically 10:47 is the first minute at which the depth is above 3.8, but with the numbers we've been given, it rounds to 10:46 a.m. So the mark scheme allows both. As for the marks for this question, you get your first mark for getting that 3.8 plus 5 plus sine 2 equals 5 plus sine 2 theta, so this line, and then getting all the way down to this line over here. Okay, so this entire section will get you your first mark, like that. Oops, sorry, put a tick, like that. Okay, your second mark comes from knowing you need to add 360 to your value for 30t, so that you get a valid answer for t, so not negative. Your third mark comes from getting that t is 10.77 hours, and your fourth mark comes from getting a time of either 10:46 a.m. or 10:47 a.m. So we are told figure 4 shows a sketch of the curve with the equation x squared minus 2xy plus 3y squared equals 50. Part A is asking us to show that dy by dx equals y minus x over 3y minus x for 4 marks. Okay? The first thing I'm going to do is I'm just going to highlight our original equation, okay, so which is x squared minus 2xy plus 3y squared equals 50. So when we are being asked to differentiate something like this, what we are being asked to do is to do implicit differentiation. Implicit. And this is a way of differentiating equations with both x and y in them, where you can't just rearrange to get y equals something, as we have here, okay? So what I'm going to do to begin with is I'm going to start by writing our original equation. So we're going to start with x squared minus 2xy plus 3y squared equals 50. What I'm going to do to start off with is I'm only going to differentiate terms with just x with respect to x, okay? So what that means is we will end up with 2x minus d by dx of 2xy plus d by dx of 3y squared, which equals, and then the derivative of 50 with respect to x is going to be 0. Okay? So all I've done is differentiated terms with just an x in them with respect to x. The next step is we're going to differentiate terms with just a y in it. And the rule we're going to use to do this is going to be the chain rule. So what we're going to say is, if you have d by dx of a function in terms of y, as we have, this will be the derivative of our y function, so this is going to be d by dy of f of y, times dy by dx, okay? And this just comes from the chain rule. So, what we will end up with is 2x minus d by dx of 2xy. Remember, we're not going to do anything to this part because it's in terms of both x and y, okay? And then what we're going to do is we're going to add, so d by dy of fy. So in our case, fy is 3y squared. So the derivative of that is going to be 6y. So we're going to do plus 6y, and then times dy by dx like this, which equals 0, okay? Now, to differentiate 2xy with respect to x, what we're going to do is we're going to use our product rule. And just as a recap, the product rule says that if you have d by dx of, say, ux, so a function in terms of u, times vy, so a function in terms of y, this equals ux times the derivative of y, okay, the y function, plus your function in terms of y times the derivative of your function in terms of x, okay? So what we need to do first is we need to find ux, vy, and by extent the derivative of ux and the derivative of vy, okay? So what I'm going to do is I'm going to say that ux, so ux equals 2x and vy equals y. From here, what I'm going to do is I'm going to find the derivative of ux, which is just going to be 2, and the derivative of vy is just going to be dy by dx. Then, what we know by the product rule is to get our, derivative, we cross multiply like this, okay, and then we add the results together, all right? So, what we can say is, I'm just going to combine this all into a final thing, so we will have 2x minus, so we said d by dx of 2xy, so it's going to be ux times vy, so it's going to be minus, and then in brackets, 2x times dy by dx, plus, and then 2y, so this, okay, plus, and then we have our 6y dy by dx, which equals 0. Now that's all that's left to do is some rearranging, and we're going to take our dy by dx out and rearrange for that, okay? So, what I'm going to do is I'm going to say this becomes 2x minus, and then 2x times dy by dx minus 2y. So all I've done is taken this minus and multiplied it by both of our terms. Plus 6y dy by dx, this equals 0, okay? Now, the next step is to take out dy by dx as a factor. So we're going to have dy by dx times, and then 6y minus 2x equals, and then 2y minus 2x. Now what I've done here is this 6y and this minus 2x, I've just rearranged it to put the 6y forward to keep the minus 2x after it, and then I've taken dy by dx out as a factor, and then on the other side I've moved minus 2y plus 2x to the other side to get 2y minus 2x, okay? From here we can say that dy by dx equals 2y minus 2x over 6y minus 2x. Now notice we can divide everything by 2 to simplify it. So we say therefore dy by dx equals y minus x over 3y minus x. And what we can do is we just check our final form. So it was y minus x over 3y minus x, and we have y minus x over 3y minus x. So that's all good, and we can write as required, like that. And then we are done with our question. So this question is worth 4 marks. Your first mark comes from either getting that the derivative of 3y squared is 6y times dy by dx, so as we have here, or for correctly differentiating 2xy and getting that it is 2x times dy by dx plus 2y as we have here. So doing either of those correctly will get you your first mark. So we've done the first step correctly, so we'll just put a tick by this little section here, okay? Your second mark comes from differentiating all the terms correctly and getting them sort of in this line here, okay? So representing them this way gets you your second mark. Your third mark comes from rearranging and taking dy by dx out as a factor, so as we have on this line. So this is worth your third mark. And then your final mark comes from doing the necessary algebraic simplifications to get dy by dx equals y minus x over 3y minus x as required. So we are told the curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q represent points that are furthest west and furthest east of the origin O, as shown in figure 4. So figure 4, see P and Q. It says using part A, part B is asking us to find the exact coordinates of the point P for 5 marks. So I'm just going to highlight some key points. I'm going to highlight that the points P and Q are furthest west and furthest east. Okay. I'm going to highlight we need to use part A, and I'm going to highlight we need to find the exact coordinates of the point P. So now we have this information. Let's get started. So the way we're going to go about solving this is we're first going to look at our vertical tangents P and Q. Okay. At P and Q, the tangents are vertical lines, and vertical lines have a change in x of 0. Okay, so this means our gradient function is going to be some change in y divided by 0. And the problem when you divide by 0 is, mathematically you can't do it. It doesn't make sense. Okay, but what we can say is we can say the tangent or the gradient at P and Q approaches infinity. Okay, because this is infinitely steep. Okay, so you can say what I'm going to write is I'm going to say at P and Q, dy by dx approaches infinity. Okay, and the whole thing for saying that is you can't say dy by dx equals infinity because infinity isn't a number. But what you can say is you can say it approaches infinity. So that sort of solves our problem. Okay. Now, if we use the fact that dy by dx approaches infinity, we can actually use this to figure out what the next step would be. Okay, so as a rule, if you have a over b approaches infinity, what this means is it means that b equals 0. Okay, so this is something you kind of have to sort of see for yourself, because if you have y minus x over 3y minus x approaches infinity and you rearrange that, what you end up with is 3y minus x equals 0, because that's the only way you can have that. Okay, so anything over 0 approaches infinity, and if y minus x over 3y minus x approaches infinity, it means 3y minus x equals 0. Okay, so from here what we can say is therefore 3y minus x equals 0. Okay, so what I'm going to do next is I'm going to rearrange 3y minus x to just put it in terms of x. Okay, so we're going to say 3y minus x equals 0, therefore x equals 3y. And what I'm going to do is I'm going to plug x equals 3y into our equation for our curve. Okay, so what I'm going to say is this implies that 3y squared minus 2 times 3y times y plus again 3y squared equals 50. So all I've done is I've put in 3y into here and 3y into here, okay, using that x equals 3y. So what we can do now is we can expand this, solve this as a normal equation and get our answer. Okay, so 3y squared is going to be 9y squared minus, so we have 2 times 3y times y, so this is going to be minus 6y squared, and then plus 3y squared equals 50. 9 minus 6 is 3. 3 plus 3 is 6. So we're going to end up with 6y squared equals 50. And then dividing both sides by 2, we get 3y squared equals 25. And y squared equals 25 over 3. Okay? Y equals plus or minus 5 over root 3, and rationalizing our denominator we get y equals plus or minus 5 root 3 over 3. Okay, but so we've got two solutions here, but the point only has one solution because that's the definition of a single point. Now if we come to our question, we need to find the exact coordinates of point P. If we look, point P here has a negative y value and a negative x value. So from here, what we can say is, since point P has a negative y value, okay, we can say the y coordinate of P equals minus 5 root 3 over 3. Okay? The final step is to find our x coordinate, and we know that x equals 3y. So all we need to do is do
3 times, and then brackets minus 5 root 3 over 3, and say this equals minus 5 root 3. Alright? Finish it off by writing it nicely and neatly. We say, therefore, point P equals minus 5 root 3, comma, and then minus 5 root 3 over 3. So this question is worth 5 marks. Your first mark comes from understanding that at P and Q, dy by dx approaches infinity, and therefore 3y minus x equals 0. Your second mark comes from solving either y equals 1 over 3x and x squared minus 2xy plus 3y squared equals 50 simultaneously, or doing x equals 3y and x squared minus 2xy plus 3y squared equals 50 simultaneously. So that's what we have done, and so that gets us our second mark. So just somewhere where the examiner can see you've attempted to do it gets you your second mark. Your third mark comes from either getting x equals plus or minus 5 root 3 or y equals plus or minus 5 root 3 over 3. So if you solved it in terms of x, you would get the first answer. If you solved it in terms of y, you would get as we have gotten here. So that's that answer. Your fourth mark comes from using your earlier equation, so that x equals 3y or y equals 1 over 3x to get the other value. So if you worked out x, the fourth mark comes from finding y, and if you worked out y, your fourth mark comes from finding x. So we've worked out x here, so we get that mark. And then your fifth mark comes from giving your final point in the correct form, so both of them have negatives. Part C has asked us to explain briefly how to find the coordinates of the point that is furthest north of the origin. Okay, and bear in mind, we do not need to carry out any calculation for this question, so I'm just going to highlight that. I'm going to highlight that we need to find the point furthest north. So the point furthest north is somewhere about here, okay? And if you were to draw a tangent, what you would notice, sort of, is this tangent is 0. So the gradient of the tangent is 0, okay? So it's going to be a horizontal line. What that means is that you would end up with dy by dx equals 0, because the gradient of the tangent is 0. So what this means is y minus x over 3y minus x equals 0. And then, by extent, y minus x equals 0, okay? Because you multiply both sides by 3y minus x, and then you just get y minus x equals 0. So we have this equation, which we've come out from using the fact that the tangent has a gradient of 0. So all you need to do is, so rearranging this one actually gets us y equals x. So all you need to do is solve y equals x, and our original equation, which is x squared minus 2xy plus 3y squared equals 50, simultaneously, okay? And then from here, you would choose a positive solution, because if we look here, our furthest north point has positive x and positive y. So, and choose positive solution, like that. And this question is worth 1 mark, and you get 1 mark for writing exactly what I have written here. Height above ground, h meters, of a passenger on a roller coaster can be modelled by the differential equation dh by dt equals h cosine of 0.25t all over 4t, where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, part A is asking us to show that h equals 5e to the 0.5 sine of 0.25t, okay, for 5 marks. First, I'm going to highlight some key information. I'm going to highlight the units, so h meters, and time is in seconds. And I'm also going to highlight at 5 meters above the ground at the start of the ride, okay? So, how do you go about this? Well, what we first need to do is collect all h related terms to one side and all t related terms to the other side.
What I'm going to do is I'm going to divide both sides by the h and times both sides by dt. So we will get 1 over h dh equals cosine of 0.25t over 40 dt. Okay, so all I did was bring the h to the denominator here and bring the dt up to here. Okay. Next, we are going to use the rule that if a times dx equals b times dy, then the integral of a dx equals the integral of b dy. Okay, where a and b are functions or constant, whatever the case may be, just something before the differential. So what we're going to do is we're going to integrate both sides. Okay, so we're going to say the integral of 1 over h dh equals the integral of cosine 0.25t over 40 dt, like that. The integral of 1 over h is ln h, so we have here ln h equals, now the integral of cosine of 0.25t over 40, what we can do is we can just do this by inspection. So cosine integrates to sine, so it's going to be sine of something. 0.25t, if you were to take the differential of it, you would get 1 over 0.25, which means 4. So it is going to be 4 over 40 times the sine of 0.25t plus c, because we're integrating, we need our constant of integration. Alright, simplifying this a bit means we have ln h equals 1 over 10 times sine of 0.25t plus c as such. Okay, now we need to find the value of our constant c. Okay, and how do we go about that? Well, if we come back to our question, we are told, given that the passenger is 5 meters above the ground at the start of the ride, this means that at t equals 0, h equals 5. Okay, so what we can do here is we can say that ln 5 equals 1 over 10 times the sine of 0.25 times 0 plus c. And if we were to look at this, 0.25 times 0 is 0, so sine of 0 is also 0, and 1 over 10 times 0 is 0. This means that c equals ln 5. Alright? Let's plug this all back into our equation. So we have ln h equals 1 over 10 sine of 0.25t plus ln 5. What I'm going to do is I'm going to subtract ln 5 from both sides. Okay, so we're going to have ln h minus ln 5 equals 1 over 10 times the sine of 0.25t. I'm then going to rewrite this. So we're now going to use the rule that ln a minus ln b, equals ln of a divided by b, as like that. Okay, so we're going to say ln of h over 5 equals 1 over 10 sine of 0.25t. What I'm going to do, the final step, is I'm going to rewrite 1 over 10 as 0.1. And then, so actually let's just write that first. So I'm going to rewrite this as 0.1, like that. We're going to take the exponential of both sides, and we're going to use the rule that if ln a equals b, then e to the ln a equals e to the b, and by extent a equals e to the b, like that. Okay, so we will be able to write that h over 5 equals, so we take an e to the ln of h over 5, so just h over 5 equals e to the 0.1 sine 0.25t, and therefore h equals 5e to the 0.1 sine of 0.25t. Okay, and then we can just write here as required. So this question is worth 5 marks. Okay, Your first mark comes from getting this line here. So that is rearranging your h and your dt and knowing you need to take the integral of both sides. Your next 2 marks come from this line, which means you have correctly integrated 1 over h and cosine 0.25t all over 4t. Okay, you need to have your plus c. Your 4th mark comes from knowing that t equals 0, h equals 5, so using that information. So this line here to get c equals ln of 5 is enough for your 4th mark. And then your 5th mark comes from getting the final answer. So it's a lot of work and algebraic manipulation to get your 5th and final mark. Okay, part B is asking us to state the maximum height of the passenger above the ground. So if we look at our expression for h, the only thing which controls the maximum height is our sine of 0.25t. Okay, so to find the maximum height, we need to find, maximum value of sine of 0.25t. Okay, so if we look at our sine graph, which I'm just going to draw very quickly here, like this, because t is positive, we don't need to consider the negative. Okay, we know that the maximum value of any sinusoidal function like this, in this term, is going to be 1, alright? So, we know that max h occurs when sine of 0.25t equals 1, alright? So therefore, if we say h equals 5e to the 0.1 times 1, because we're substituting 1 for our sine of 0.25t, this means it equals 5e to the 0.1. If I check on my calculator, the value for 5e to the 0.1 is 5.5258, etc. We're going to round that to 2 decimal places, call that 5.53 meters. Okay, make sure to include the units. This question is worth 1 mark, and that 1 mark comes from getting the final answer. We are told a passenger reaches the maximum height for the second time t seconds after the start of the ride. Part E is asking us to find the value of t, for 2 marks. So from before, we know that h is max when sine of 0.25t equals 1. So what we need to do is we need to find the values of t for which sine of 0.25t is 1. So this means, actually, let me write that in black. This means we need sine of 0.25t equals 1. 0.25t equals the inverse sine of 1. And to find what these values are, what I'm going to do is I'm going to draw a quick sine curve like this, and we are going to label first off some key values. So we know our first peak occurs at pi over 2. We know it reaches 0 at pi and at 2 pi. And this point here is the end of a single sine cycle as such. Okay. So the inverse sine of 1 is basically looking to find which values give us a answer of 1. So when we take the sine of which x values do we get 1? We can see here that this means that 0.25t would either equal pi over 2, which is the first t, or it would equal pi over 2 plus 2 pi, i.e. this point here, so pi over 2 plus 2 pi is 5 pi over 2. Like this, okay? Now, if we look at our question said the passenger reaches a maximum height for the second time t. So we need to find which t value is the second one, and that is 5 pi over 2. So we're going to write something like 5 pi over 2 is the second value. So what we do is we say 0.25t equals 5 pi over 2. To get t on its own, we time both sides by 4, so t equals 4 times 5 pi over 2, and t equals, well, 4 times 5 is 20, 20 over 2 is 10, so 10 pi, which equals 31.4 to 3 significant figures. Okay, and for this question it is worth 2 marks. Your first mark comes from doing the necessary working to know that 0.25t is 5 pi over 2, and your final mark comes from getting the correct answer of 31.4. Note you don't need the unit second, because in our question it just asks us to find the value of t. Okay, and we are told that it is t seconds, so if we give t as 31.4 seconds, it's going to be 31.4 seconds, which doesn't make sense. We are asked to use the binomial expansion to show that the square root of 1 plus 4x over 1 minus x is approximately 1 plus 5 over 2x minus 5 over 8x squared, for 6 marks. Okay, so the first rule that I'm going to use to solve this is I'm going to say that if you have the square root of a over b, this equals the square root of ab to the minus 1, okay, which equals a to the 0.5 times b to the minus 0.5. All right, so let's apply that. So we're going to say the square root of 1 plus 4x over 1 minus x. So in this case we're going to let our a be 1 plus that broke across, a be 1 plus 4x and our b be 1 minus x, like this. Okay, so this equals the square root of 1 plus 4x times 1 minus x to the minus 1, which equals 1 plus 4x to the half times 1 minus x to the minus a half, like that. Okay, now what we have here is we have an expression of the form 1 plus x all to the n, where n is a rational number. Okay, so it's a fraction. All right, so how do you go about expanding this? Well, if you have 1 plus x all to the n, this given that n is a rational function like that. Okay, I don't really know how to draw that properly, but this equals 1 plus nx, okay, plus n minus 1 over 1 times 2 x squared, and so on. Okay, now this is a formula which is in your formula book. All right, so you're not expected to remember this off by heart. Now the reason I'm stopping at x squared is because notice the highest term for our approximation is x squared. All right, so what I'm going to do is I'm going to use this formula and apply it first to 1 plus 4x or to 0.5, and then 1 minus x to the minus 0.5. So what I'm going to say is 1 plus 4x to the power of 0.5 equals 1 plus, now here we know our n is 0.5, okay, so this is going to be 0.5 times our x term, so times 4x, plus again 0.5 times minus 0.5 because n minus 1, all over 2 times, and then 4x all squared is going to be 16x squared, like that. Okay, I'm just going to simplify it out a bit. So we're going to have 1, so 0.5 times 4x is 2x, so 1 plus 2x plus 0.5 times minus 0.5 is minus 0.25. Okay, minus 0.25 over 2 is minus 0.125, and then minus 0.125 times 16 is the same as 16 divided by minus 8, which is minus 2. So it's actually going to be minus 2x squared. Okay, now let's apply the same thing for 1 minus x. So 1 minus x to the power of the minus 0.5 in this case equals, again, 1. Now we need to do minus 0.5 times minus x. So that's going to get us positive 0.5x. All right, like that. And then it's going to be plus minus 0.5 times minus 1.5 all over 2 times, and then minus x squared is just going to be x squared. Okay, simplifying this gets us 1 plus 0.5x plus minus 0.5 times 1.5, so that's just going to be 0.5 times 1.5, which is 0.75. 0.75 divided by 2 is 0.375x squared. So 0.375x squared. Okay? Now what we need to do is we just need to expand the brackets. So what we need to say is 1 plus 4x to the 0.5 times 1 minus x to the minus 0.5 equals, and then just in brackets, 1 plus 2x minus 2x squared times 1 plus 0.5x plus 0.375x squared, like this. Okay. Now what we need to do is expand the brackets. Okay. So all I'm going to do, I'm going to expand up until the x squared term, because if we go back to our answer, okay, our answer had an x squared term in it. So we're going to start 1 times 1, okay, is 1. So this is going to equal 1. And then 1 times 0.5x is 0.5x, so plus 0.5x. 1 times 0.375x squared is plus 0.375x squared. And now we're just going to repeat this. So we've got 2x times 1, which is 2x. So I'm going to write them under here just to keep the x's and the x squareds together. And then 2x times 0.5x squared is going to be 2 times 0.5, so 1x squared. So plus x squared. And then the final step is to do minus 2x squared. I need to fix that properly. Minus 2x squared times 1, which is going to be minus 2x squared. Okay? What we can do now is we can add all of these. So what we will end up with is 1 plus 2.5x, and then 0.375 plus 1 is 1.375 minus 2. So if I just check on my calculator, 1.375 minus 2 is minus 0.625. So minus 0.625, sorry, x squared. Okay. Now look in our question, we've been given it as a fraction. So as good practice, we are going to convert our answer into a fraction. Okay. So we're going to say, therefore, the square root of 1 plus 4x all over 1 minus x is approximately 1 plus, and then 2.5 is the same as 5 over 2 x, and then minus 0.625 is the same as minus 5 over 8, so minus 5 over 8 x squared as required. Okay, so this question is worth 6 marks. Okay, your first mark comes from converting the square root of 1 plus 4x over 1 minus x into this form here. Okay, so that gets you your first mark. Your next 3 marks come from correctly expanding and getting the answers for 1 plus 4x to the 0.5 and 1 minus x to the minus 0.5. Okay, so you get 1 mark if you got either correct, but if you got both correct, you get 3 marks. So the fact that we've gotten this one right and this one right means we get our 3rd mark. Okay? Your 5th mark comes from getting this sum here. Okay, so writing that down, so expanding only the correct and necessary terms gets you your 5th mark, and then your 6th mark comes from getting the correct final answer as required. Part B is asking us to give a reason why the student shouldn't use x equals a half. Okay, when looking at what values you can't use, you need to look at the validity of the expansion. Okay. And as a general rule, an expansion in the form p plus qx all to the n is valid when the modulus of qx over p is less than 1, like that. Okay. Rearranging this, we get qx is less than p, and therefore x is less than p, modulus of p, sorry, over the modulus of q, like that. Alright? So what we're going to do is we're going to find the validity for both 1 plus 4x and 1 minus x, and whichever one is smaller, that's the one we're going to use. Okay, so let's take a look. So for 1 plus 4x, okay, our p is 1, right, and our q is 4. Okay, so therefore it is valid when the modulus of x is less than 1 over 4. Alright? If we take 1 minus x, it is valid for, if we just apply the same thing, when the modulus of x, because q is minus 1, so the modulus of q is 1 and p is 1, so 1 over 1 is going to be 1. Okay? As we can see here, 1 over 4 is smaller than 1, so the 1 over 4 is what we're going to use for our argument. Alright, so what we need to do is we need to say something along the lines of expansion is valid when the modulus of x is less than 1 over 4. Since x equals a half is greater than 1 over 4, which it is, okay, we shouldn't use x equals a half. So this question is worth 1 mark, and the 1 mark just comes from completing your argument as such. Part C is asking us to substitute x equals 1 over 11 into our approximation for the square root of 1 plus 4x over 1 minus x to obtain an approximation to root 6. We are told to give our answer as a fraction in its simplest form. So this question actually is pretty straightforward. All we need to do is plug in x for 1 over 11 into our expansion here and here, as well as substituting our value of x equals into 11 into each of our x terms here. And all we need to do is just solve it and rearrange to get root 6. Alright, so let's go on to that. We're going to say at x equals 1 over 11, the square root of 1 plus 4x over 1 minus x equals the square root of 1 plus 4 over 11. So if I put that into my calculator, okay, 1 plus 4 over 11 is 15 over 11, like this, all over 1 minus 1 over 11, which is 10 over 11, like that. Simplifying this, we have over 11 on both sides, so this just equals the square root of 15 over 10, and 15 over 10 simplifies to 3 over 2. So this equals the square root of 3 over 2. Now, we can say again, at x equals 1 over 11, okay, just substituting it into our approximation, we have 1 plus 5 over 2x minus 5 over 8x squared equals 1 plus, now 5 over 2 times 1 over 11 is 5 over 22, okay, minus, and then 5 over 8 times 1 over 11 squared gets us 5 over 968, okay? What I'm going to do now is I'm just going to sum these up on my calculator just to get a final expression, which is 1183 over 968. So therefore, what we can write now is root 3 over 2, sorry, root 3 over root 2 equals 1183 over 968. If we look, root 6 equals root 3 times 2, which is root 3 times root 2, okay? And we already have root 3 over root 2. So to get from root 3 over root 2 to just root 3, we need to do root 3 over root 2 times root 2 gets us just root 3, okay? And then to get from root 3 to root 6, we need to do root 3 times root 2 equals root 6, like that. So what we've done is we've multiplied root 3, so in conclusion actually, I'm just going to write it like this, okay, root 3 over root 2 times root 2 times root 2 gets us our root 6. Root 2 times root 2 is the same as 2, so therefore what we can say is root 3 over root 2 times 2 equals root 6, alright? And therefore, root 6 equals 1183 over 968 times 2, okay? And what this equals is 1183 over 484, alright? So what we can say in conclusion, therefore, root 6 equals 1183 over 484. So this question is worth 3 marks. Your first mark comes from, actually doing the substitution. X equals 1 over 11 into both the square root of 1 plus 4x over 1 minus x and 1 plus 5 over 2x minus 5 over 8x squared. So you need both of these two things to get your first mark. Your second mark comes from setting them equal to each other. And your third mark comes from doing the necessary work to get your final answer. We are told the value V pounds of a vintage car 2 years after it was first valued on the 1st of January 2001 is modeled by the equation V equals AP to the power of t, where A and P are constants. It is given that the value of the car was £32,000 on the 1st of January 2005 and £50,000 on the 1st of January 2012. Part A is asking us to find first P to 4 decimal places, and then to show that A is approximately 24,800 for 4 marks. So the first thing I'm going to do is I'm going to pick out some key information. The car was first valued on 1st of January 2001. Okay, it was 32,000 on the 1st of January 2005 and 50,000 in 2012. Okay, so to find P, what we need to do is we need to solve the equation using the information we have to begin with. So we know that in 2005, okay, the number of years after 2001, which is t, is 4, so t equals 4, and therefore we have 32,000 equals a p to the power of 4. And then in 2012, t was 11, okay, because we're doing 2012 minus 2001 is 11 years, and this means that it was valued at 50,000 equals ap to the power of 11. Okay, so what we can notice here is both of our sort of expressions here have a and p, but notice both of them have just a on its own. So what we can do is we can say that ap to the 11 over ap to the 4 equals 50,000 over 32,000. Okay, this means that so a and a will cancel out. Okay, so we're just left with p. So this means that p to the power of 7 equals 50,000 over 32,000. Okay, the thousands cancel, so we'll just have 50 over 32. And then what this means is p equals the 7th root of 50 over 32. Okay, and when you put this into your calculator, you will get p as being equal to 1.0658, and we're going to stop after 4 decimal places because the question said find p to 4 decimal places. Okay, now the next step is to find our value of a, or to show that a is approximately 24,800. Okay, so actually let's just put I here and then moving down I. Okay, from above we know our equation is v equals ap to the t. So what I'm going to do is I'm just going to write that down here. Okay, so v equals ap to the t, like that. Alright, what we can do is we can use one of our pre-existing equations, so say this one here, 32,000 equals ap to the 4, and plug in our value of p to solve for a. So what this means we would get is 32,000 equals a times 1.0658 to the power of 4. Okay, and solving this we would get a equals 32,000 divided by 1.0658 to the power 4. Remember, show all your steps, okay? And therefore, what we get, so if I take my calculator and I put this into there, okay, so we have 32,000 over 1.0658 to the power 4, we will get 24,799.73, etc. Okay? Now, this answer, okay, is extremely close to, so if we were to round it to 3 significant figures, it would be 24,800. So what we could say is something along the lines of 24,799.73, etc. to 3SF is 24,800. Okay? And you say, therefore, A is approximately 24,800 as required. This question is worth 4 marks. So you get 2 marks for part I, and the 2 marks come from first coming up with a suitable method to solve for P. So this up to here, all the work above would be enough sufficient evidence to get you your first mark. Your second mark comes from getting the correct answer to P. And then part II is also worth 2 marks. Your first mark comes from rearranging A out of the equation to get something along the lines of this. So this line here is sufficient evidence for your first mark of that part, and then getting 24,800 as as needed gets you your second mark. Part B is asking us, with reference to the model, interpret I, the value of the constant A, and II, the value of the constant P. Okay, so if we look at the constant A occurs when t equals 0. So the car will be valued at 24,800 when t equals 0. Because at t equals 0, okay, v equals a p to the 0, and this means that v equals a. Okay, so it's the value at the start of the time period. So what you would write is A is the value of the car on the 1st of January, yes, got that right, 2001. Okay, now II is how much, or the sort of scaling of how much the car increases in value each year. Okay, so it's the factor by which the value rises. So what you would need to write in that case is, I would write 2 statements here just to be safe. So I would say first that P is the factor by which the value increases, or you could also use the word rises each year. Okay, now the other thing I would say, let me just correct that actually, each year, I would also say that the value rises by, so if we look, 1.0658, that's close to 1.066, so I would say the value rises by 6.6% each year. Okay, just to be safe, and because it says interpret with reference to the model, so saying technically on its own that the factor by which the value increases in some mark schemes might not be enough. So by saying the value rises by 6.6% each year, you are directly applying it to the situation. Again, this question is worth 2 marks. You get 1 mark for part I and 1 mark for part II, and that is for writing as I have written here in both cases. Part C is asking us, using the model, find the year during which the value of the car first exceeds £100,000 for 4 marks. I'm going to highlight where it says find the year, okay, because it shows we need to give a final year as our answer. To solve this question, what I'm going to do is I'm going to substitute 100,000 for our value of v. So we will end up with the equation 24,800 times 1.0658 t equals 100,000. Okay? Rearranging this, we're going to get 1.0658 to the power of t equals 100,000 divided by 24,800. Okay? Now I'm going to use a rule which states that if a to the x equals b, then x equals the log base a of b. Alright? So, what we will do is, if we say our a is 1.0658, our t is x, and our b is 100,000 over 24,800, okay, we will know that t equals the log of base 1.0658 of 100,000 all over 24,800, like this, okay? Put it into your calculator, you will get a value of t as 21.88 years, okay? Now remember, our question asked us to find the year in which the value exceeds 100,000. So the year is going to be 21 years after 2001. So 21 years after 2001 is 2022. So we would say, therefore, the year the value of the car exceeds £100,000 is 2022. So this question is worth 4 marks, okay? Your first mark comes from getting this line over here, so having 1.0658 to the t is 100,000 over 24,800. Your second mark comes from solving for t, so getting this formula over here. Your third mark comes from getting t as being anywhere between 21.8 and 21.9, depending on whether you use the exact values or the approximations the examiner gave us. And your final mark comes from getting a year of 2022. We have been asked to show that the integral from 0 to 2 of 2x times the square root of x plus 2 with respect to x is 32 over 15 times 2 plus root 2 for 7 marks. So the first thing I'm going to do is I'm going to rewrite the integral, but I will be changing the square root of x plus 2 to x plus 2 to a half, like that. Okay, and it's just going to make it easier, because if we look at our original integral, the square root of x plus 2 is kind of what's causing the big problem. Okay, so what I'm going to do first, I'm going to make a u substitution and let u equal to x plus 2. Okay, we will then say du by dx equals, well, the derivative of x with respect to x is 1, and the derivative of 2 with respect to x is 0, so it's going to be 1 plus 0, which is just 1. This means that du equals dx. Okay. The next thing I'm going to do is I'm going to rearrange u equals x plus 2 for x. So we're going to say that x plus 2 equals u, and therefore x equals u minus 2. The final step is I'm going to change both of the limits from the x world to the u world. So what I'm going to say is I'm going to say that at x equals 2, u equals, so we have our rule here that u equals x plus 2, so u is going to equal 4, and at x equals 0, u equals 2. So what I'm going to do now is I'm going to plug in all what we've done. Okay, so I'm going to say the integral, so the bottom limit is 2 and the top limit is 4. 2x is 2 times u minus 2, so it's going to be 2u minus 4, times x plus 2 to the half. Well, x plus 2 is u, so it's going to be u to the half. Okay, and then it's going to be du, like this. Okay, I'm going to expand the brackets out now, so it's going to become the integral from 2 to 4 of, let me just actually rewrite this to make it neater, 2u times u to the half, so that's going to be 2, and then u to the 1 plus half is going to be u to the 3 over 2, okay, and then minus 4u to the half du. Okay, so all I've done here is I've done 2u times u to the half and minus 4 times u to the half. Evaluating this integral, okay, we will end up with 2u to the 3 over 2. So you add 1 to the power, divide by the new power. So we will get 2u to the 5 over 2 divided by 5 over 2 minus, and then 4u to the 3 over 2 divided by 3 over 2 again, like this. And then from 2 till 4. There we go. Simplifying this and rearranging the fractions, we will end up with, so 2u to the 5 over 2 divided by 5 over 2 is the same as 2u to the 5 over 2 times 2 over 5. So what we will end up with is 2 times 2, so 4u to the 5 over 2 divided by 5 minus, and then the same thing applies here, we're going to end up with 8u to the 3 over 2 divided by 3. Okay, from 2 to 4. Alright. Now what we're going to do is we're going to substitute our limits into our results. So we're going to put 4 for u and 4 for u again, and then we'll come back and we'll do 2. So this equals 4 times 4 to the 5 over 2 over 5 minus 8 times 4 to the 3 over 2 divided by 3. Okay, so that's the first part. Minus, now what we need to do is we need to plug 2 in, okay, for each of our u's, and we will get 4 times 2 to the 5 over 2 over 5 minus 8 times 2 to the 3 over 2 divided by 3. Okay? Now, if you were to plug these into your calculator, what you would get is this equals 128 over 5, okay, minus 64 over 3, minus, so this minus is applied directly to this term here, minus 16 root 2 over 5, and then minus, and minus is a plus, so it's going to be plus 16 root 2 over 3. Okay? Summing all these together, you will end up with 64 plus 32 root 2 over 15. And what we can do here is we can say this equals 32 2 plus root 2 over 15. And then using the rule that if you have a, b over c, this equals a over c times b, we can say this in turn equals 32 over 15 times 2 plus root 2, and we can write as required, like that. So in terms of the marks, this question is worth 7 marks, okay? Your first mark you will get for attempting to use any valid u substitution and integrating using appropriate limits. Okay, so any type of u substitution you've done and any sign of changing the limits gets you your first mark. Your second mark comes from doing the u substitution of u equals x plus 2 and getting by extent that dx by du equals 1. So showing that, so doing this line here and this, getting this result here, will be enough to get us both of our first 2 marks. Okay. Your third mark comes from correctly substituting all your terms in terms of u into the original integral, okay, to get something of this format. Your fourth mark and fifth mark kind of come together in that you get your fourth mark if you've got anything times u to the 5 over 2 plus anything times u to the 3 over 2. But if you've gotten exactly 4 over 5 times u to the 5 over 2 minus 8 over 3 times u to the 3 over 2, as we have here in our solution on this line, you will get both of your marks. So we get 2 marks for this line. Okay, your sixth mark comes from correctly putting in the limit and solving it, and your seventh mark and final mark comes from getting 32 over 15 times 2 plus root 2 as required. We are told a curve C has parametric equations x equals 3 plus 2 sine t and y equals 4 plus 2 cosine 2t, where t is between 0 and 2 pi. Part A is asking us to show that all points on C satisfy y equals 6 minus, and then brackets x minus 3 all squared. So what the question is asking us to do, it's asking us to convert our parametric equation to Cartesian form. Okay? So the way I'm going to go about doing this is notice how we have a cosine 2t in our parametric equation for y. And what I'm going to do is I'm going to actually use the identity that cosine of 2t equals 1 minus 2 sine squared t. Okay? And the reason I wanted to do this was because notice how we have a sine t term for our x parametric equation. Okay? So if y is 4 plus 2 cosine 2t, this means that y equals 4 plus 2, and then in brackets 1 minus 2 sine squared t. Okay? Which equals 4 plus 2 minus 4 sine squared t. And then we can actually take this one step further and we can say y equals, so 4 plus 2 is 6, 6 minus, and now 4 sine squared t can be written as 2 sine t all squared like that. Okay? Now we're going to take our x parametric equation and rearrange it. So we're going to say, since x equals 3 plus 2 sine t, it means that 2 sine t equals x minus 3. Okay? So all we need to do is plug in our value or expression for sine t into our y. Let's just make that arrow nicer, like that. And then we will get, this means that, therefore, y equals 6 minus, and then 2 sine t is x minus 3 squared. And then we can see this is what we needed, so we will write as required. This question is worth 2 marks. You get your first mark for attempting to use cosine 2t equals 1 minus 2 sine squared t. So this line here gets you your first mark. And then your second mark comes from concluding your proof. Part B has 2 parts. Part I is asking us to sketch the curve C, and part II is asking us to explain briefly why C does not include all points of y equals 6 minus x minus 3 all squared where x is real, for 3 marks. Okay? So if we look at our expression, so function, we've got y equals 6 minus x minus 3 all squared. So we know that this is going to be a parabola. Okay? And furthermore, what we also know is that because it has a negative over here, it's going to be sort of an N shape. So it's going to be something like this. Okay? So let's come down to here and let's see what we can work out. Let me just draw the general shape of our parabola over here. We're going to have 2 endpoints like this, and we're going to have 1 turning point up here. Okay? So let's look at how we can find these points. When we are looking at, say, our turning point to begin with, so this top point here, okay, it is going to be the maximum value of y. Okay, and to get the maximum value of y, we need cosine to be a function of 0. So we will need 2t to equal to 0, or t to equal 0. So we say max y equals 4 plus 2 times the cosine of 0, which equals 4 plus 2, which equals 6. So we know our turning point is going to be something, comma, 6. Okay? Now, if we want to look at our y coordinates for our endpoints, we see they are at a minimum. What we need to do is we need to look for when y is at its lowest. Y is at its lowest when cosine of 2t equals minus 1. So this means 2t equals the inverse of minus 1, which equals pi, and therefore t equals pi over 2. Okay? Pi over 2. So by extent, we can say min y is when 4 plus 2 times minus 1, which is 4 minus 2, which equals 2. So we know both of our points here are going to be something, comma, 2. Okay? Now, let's look for our x points. All right. This point here, okay, has the smallest x value. So that's going to be when x is at its minimum. Okay? So what we need to say, so say min x is when sine of 2t equals minus 1. So therefore, min x equals 3 minus 2, because we've got minus 1 times 2, so that's minus 2, which equals 1. So this point here is 1. And then max x is when sine of 2t equals 1, and therefore the max of x is 3 plus 2, which equals 5, like this, okay? Now, we still need to find the x-coordinate of our turning point, and what you can notice is our turning point for any parabola is in between the two endpoints, okay? So, just to find, in principle, the midpoint between 1 and 5, you do 1 and 5, add them together, which is 6, and then you divide by 2, which is 3. So that means the x-coordinate of our turning point is 3, 6, okay? So what we can come do now is come back to our graph, and we can just sketch it on, okay? So draw an N-shaped parabola, like this, okay? You just make sure they finish sort of approximately at the same point. And then now what we're going to do is we're going to label our points. So this point here, as we said, is 1, 2. This point here is 5, 2. And this point here is 3, 6. Okay? And let's just check 3, 6, 5, 2, and 1, 2. Okay? That's good, as required. Okay? Now for II, okay, just the final bit, all we need to do is give one reason why it doesn't take all real x values, okay? And the main reason is because since t takes the range, the domain of 0 to 2 pi, okay, the x value, so x equals 3 plus 2 sine t, can only go from when sine t is minus 1 to 1. So x equals 3 plus 2 sine t can only take when sine t is between minus 1 and 1. So when you use these brackets, it means sort of in the range of, okay? So you would say, therefore, x is in between 1 and 5. So this question is worth 3 marks. You get 2 marks for your parabola, and in these 2 marks you get 1 for the correct sort of shape, so like the N shape, and then you get your second mark for getting the correct points. So I'm just going to write here correct point equals your second mark, okay? And then for part I, so, you know, the second part, you get 1 mark for a correct reason, so any suitable statement as we have here. We are told the line with the equation x plus y equals k, where k is a constant, intersects C at 2 distinct points. Part C is asking us to state the range of values of k, writing our answer in set notation for 5 marks. So I'm going to highlight some key points. We're told that it intersects C at 2 distinct points. We need to state the range of values of k, and we need to give our answer in set notation. Okay, so these are all important. What I'm going to start off by doing is I'm just going to draw, you know, a line, all right, like this, okay? And we're going to say the line takes equation x plus y equals k, okay? And what I'm going to do is I'm going to just move it up and down the graph just to see what happens. So as we keep going like this, okay, we see there is, up until a certain point, there is only 1 point of intersection until we reach the point 5, 2, okay? At this point is our first point of 2 points of intersection, okay? We have our intersection at 5, 2, i.e. the end of the parabola, and some other arbitrary point. It's not 3, 6, it's just some other point. So what we're going to say is, we're going to say the first time 2 intersections occur, okay, we say at 5, 2, okay? So at point 5, 2, we have our first instance of the equation x plus y equals x intersecting with our curve C, okay, twice. So what we can start off by saying is that at this point here, we have x equals 5 and y equals 2. So we can say for x plus y equals k,
at 5, 2. Now what we do is we plug in 5 for x and 2 for y, and then we would get k equals 5 plus 2, which equals 7. Okay, so the minimum value k can be for two distinct points of intersection is 0.7. Okay, to find our upper value for k for when the intersection between C and our line x plus y equals k has 2 points, we need to see the last k value, or value for k, that would enable this. So if we keep moving our line up, we will reach eventually this point over here. Okay, and this is going to be the boundary between where there are 2 points of intersection and where it becomes a tangent. Okay. So the way we would go about this is we would say something along the lines of since x plus y equals k, y equals k minus x. Okay, and then we would take our equation y equals 6 minus x minus 3 all squared, and we will substitute our value of y for k minus x. Okay, so we will get something along the lines of 6 minus x minus 3 all squared equals k minus x. Okay, so expanding this out, we get 6 minus, and then x squared minus 6x plus 9 equals k minus x. So we have 6 minus x squared plus 6x minus 9 equals k minus x. Now rearranging, we will have minus x squared, 6x, we will take this minus x and bring it to the other side to get 7x, so plus 7x. And then we are left with 6 minus 9, which is minus 3, and then minus k. So minus 3 minus k equals 0, like that. To just make this nicer to work with, we will say x squared minus 7x plus 3 plus k, so multiply everything by minus 1 equals 0. Okay? Now, what we need to do is, because we are looking for the limit, so like the final point, is we need to find where, or at what x value, there is only one point of intersection. Okay? And one point of intersection means a tangent, and the way we find a tangent to a curve is we use the discriminant. So we would say final k value is when b squared minus 4ac equals 0. Okay, so this is when the discriminant of the quadratic we have over here is equal to 0. So what we'd say is we would say a equals 1, b equals minus 7, and c equals 3 plus k. We can take all this and we can say 49, so b squared minus 4a, and then 3 plus k equals 0. So we say 49, and then minus 4 times 3 is minus 12, and then minus 4 times k is minus 4k, like this, equals 0. 49 minus 12 is 37, so we have 37 minus 4k equals 0, and then we have 4k equals 37, so k equals 37 over 4. So what we found here is k equals 37 over 4. This is when the line becomes a tangent to the curve. Now we want to find when k has two distinct points, not one point. Okay? So what we would say is range of two distinct points is, so the first point we found was 7, so we keep that, k, but we use a strict inequality here, 37 over 4. It is not less than or equal to 37 over 4, because when it's equal to 37 over 4, it becomes a tangent, not two distinct points. Okay? So the final step is to write it in set notation. So we would say range of values for k equals, open these brackets, where k goes from 7 up to 37 over 4, like that. So this question is worth 5 marks, okay? Your first mark, you would get it for any attempt
and correctly finding either that the lower value for k is 7 or that the upper value for k is 37 over 4. So we found the lower value of k is 7, so we get our first mark. Our second mark comes from combining our x plus y equals k and our y equals 6 minus x minus 3 squared to get this line. So that's good for our second mark. Your third mark comes from getting a quadratic of this form, okay? Your fourth mark comes from getting k as being 37 over 4. And then your fifth mark comes from correctly writing the range of values for k in the correct set notation.